Good morning. In this session, we are going to discuss about electrochemistry. Electrochemistry is nothing but a part of physical chemistry which deals with the energy conversion. That is, energy conversion means electrical energy to chemical energy and vice versa. So this is what we are going to see in this electrochemistry. Before going to the electrochemical reaction, let us see some of the basic terminologies in electrochemistry. That is conductor. What is a conductor? Any substance which allows flow of electrons. So any substance or material which allows the flow of electricity is said to be a good conductor. Electrode. Electrode is any metal which conducts electricity. Based upon the chemical reaction, it is classified into anode and cathode. Anode is electrode where oxidation takes place, and cathode is a electrode where reduction takes place. Oxidation is nothing but loss of electrons, and reduction is nothing but gain of electrons. An electrolytic solution is nothing but a solution which helps the transfer of electrons from anode to cathode. So a cell, a complete cell is nothing but a setup where we have an anode, a cathode, and both the electrodes dipped in an electrolytic solution. This is a complete cell. So how will you represent this cell? Cell, it is represented by taking anode at the left hand side and cathode at the right hand side. Anode is represented by taking metal first and then electrolytic solution, and in cathode the first electrolytic solution is represented and then followed by the metal. Both the half cells are separated by salt bridge. It is denoted by two lines. Okay. So at each half cell, electrode is potential is developed. That potential is known as electrode potential or cell potential. So this difference in the potential only drives the electron from the electrode having higher potential to the electrode having lower potential. So electromotive force is nothing but the difference in the potential which allows the flow of electrons from the electrode having higher potential to the electrode having lower potential is known as electromotive force. It is the unit of this EMF is volt. Then cell potential, complete cell. So the total cell potential is the sum of potential at each electrode, that is anode and cathode. For example, if this is a complete cell, a potential will be developed at this anode and a potential will be developed at this cathode. So a sum of the potentials developed at both anode and cathode will give you the potential of this complete cell. So cell potential is nothing but sum of potentials developed at both the electrodes. Now electrode potential, we have told that potential is developed at each electrode. So now we are going to see about how the potential is developed at each electrode, that is electrode potential. For that, the first point we are going to discuss is any metal, it consists of metal ion and its valence electron. So any metal, it is made up of or it consists of metal ion and its valence electron. For example, if we take zinc, it consists of zinc metal ion and its valence electron 2 electron. If we take aluminium, aluminium is made up of or it consists of aluminium metal ion Al3+ and its valence electron 3 electron. So any metal, it consists of metal ion and its valence electron. Second point what they discuss is, so a metal consists of metal ion and its valence electron. When this metal is dipped in a solution of its own salt, two possible reactions are there. One is either the metal ion from the solution, from the metal ion from the electrode may go into the solution, or the metal ion from the solution may get deposit on the electrode. Okay, the first one is known as oxidation and the second one is reduction reaction. So when a metal is dipped in a solution of its own salt, either oxidation may take place or reduction will take place. So let us illustrate or explain this electrode potential with an example, that is taking Daniel's cell as an example, where zinc rod is dipped in zinc sulfate solution and copper rod dipped in copper sulfate solution. Here the zinc rod, it consists of Zn2+ ions and 2 electrons. Similarly, the copper rod, it consists of copper 2+ ions and 2 electrons. And this zinc sulfate solution, it consists of Zn2+ and SO4 2- ions. Similarly, copper 2 plus solution consists of copper 2 plus ions and SO4 2 minus ions. So when this zinc rod is dipped in zinc sulfate solution, the Zn2 plus ions from this metal rod goes into the solution, leaving behind the electrons. So this electrode surface becomes negatively charged. This negative ions immediately attracts the positive ions from this solution and forms an electrical double layer. Due to this electrical double layer, a potential is developed. That potential is known as electrode potential. Since this potential is developed due to the oxidation reaction, it is known as oxidation potential. Okay. Similarly, when copper rod dipped in is copper sulfate solution, the copper 2 plus ions from the solution get deposits on the surface of the copper rod. So the surface of the copper rod becomes positively charged. And this positive ions attracts the negative electrons and forms an electrical double layer. Here also potential is developed, and that potential is known as electrode potential. Since the potential is developed due to the reduction reaction, it is known as reduction potential. So generally, how will you define electrode potential? When a metal is dipped in a solution of its own salt, either loss or gain of electron takes place and a potential is developed. That potential is known as electrode potential. If the potential is developed due to oxidation reaction, it is oxidation potential. If the potential is developed due to reduction reaction, it is known as reduction potential. Very simple. That's all. So why here in zinc rod, the metal ion from the zinc rod goes into the solution, and why this here the copper 2 plus ions from the solution gets deposits on the copper rod? What is the reason? The reason behind this is here the solution will have a solution pressure, and this zinc rod will have a pressure. Okay, so due to the difference in the pressure, there is a difference in the reaction also. So this how the potential is developed at each electrode. So there are some exercises based upon the previous slides. Thank you.